Hello, everyone, and welcome to my presentation for the 2021 International Conference on Communications. I am your presenter, Chris DeSantis, and I am a member of the IoT Research Lab at Manhattan College. This will be a presentation on an MEC-based evacuation planning model, which involves the classification of speech samples obtained from mobile edge devices. The problem that our design is trying to solve is in contributing to accurate evacuation modeling. Evacuation modeling is important for estimating the safety of a building. These models can be based on a number of metrics, which include capacity and occupant characteristics, as well as the spatial distribution or the localization of the occupants. And the proposed system that I am presenting today seeks to use mobile edge computing and mobile edge devices in order to accurately predict occupant distribution within a building, specifically, in this case, the gender distribution within a building. And within the area of behavioral science, um, gender has been observed to be an important metric for evacuation modeling, since it has been studied that the behavior between genders is different in evacuation scenarios. The objective of this work is to create a system by which occupants within a building or otherwise enclosed area can be identified for evacuation modeling. And again, there are many metrics by which we can identify the occupants, but this presentation and the subsequent paper focuses on gender identification. And using an MEC system, we have an on-premises system that can run isolated from the rest of the network. So since the servers are located close to the end user, this allows for better latency performance and also for faster iterative global and local updates containing the changes in occupant distribution. This system aims to take a step in bridging the gap between behavioral science and the concepts of MEC, mobile edge learning, MEL, as well as machine learning concepts, and in doing so, to achieve a more evacuation modeling system for the benefit of the occupants. So, the system model overview. There are three distinct layers which can be outlined as the edge device layer, the edge server computation level or layer, and the cloud service layer. And each layer will be elaborated on in the subsequent slides. But basically, the data flow for the system is from the mobile edge devices to the mobile edge servers, and from the mobile edge servers to the cloud servers, and then back relaying the evacuation model to the user for deployment when needed. So to start, we have the edge devices. So with um, the occupant's consent, of course, and similarly to other products on the market now that monitor speech, such as Amazon's Alexa, the edge devices in this proposed model will be used to collect random speech samples And these speech samples will be retrieved from the mobile edge devices of the occupants within the building. And the speech data can be sent to the next layer in real time. So to update the distribution of male and female occupants. And this will lead to a more accurate assessment of the distribution of each gender within an occupied space. So next here we have the edge servers, and the edge server layer will be used for computation um, and classification of the genders of based on the speech samples. And it will also be allocated for maximizing the gender accuracy through the number of local learning iterations per global update cycle. It will have the task of receiving the speech sample data and interpreting it as either male or female. And this will be done using the feature extraction algorithm that we modeled, which uses the variance, fractal dimension, trajectory, and Mel frequency cepstral coefficients as our features of speech. Um, and once extracted, these features were put through a tuned SVM model to accurately classify the gender of the mobile edge device owner. Mobile edge learning will also be sought to be utilized at this level, as it will provide for the optimization of resources for classification by learning from the distribution of genders within an occupied area. So here is just sort of like a high level overview of the features themselves. So the variance fractal dimension is a time domain feature of speech, and it estimates the complexity of the speech signal as opposed to the energy. And by this, it is amplitude independent, and it provides a multi-scale temporal approach to deal with noisy speech signals, which is important for accurate classification. The image here depicts the change in the VFD values over time. So as you could see, when there's speech present, there is a different characteristic of the VFD. The next feature used was the Mel frequency cepstral coefficients. And this is a feature extracted from the frequency domain. It is representative of how humans perceive sound, which is not linear but logarithmic. Um, so, since the speech information is condensed into 13 coefficients, FCCs, the dimensionality is reduced, and this further leads to a better latency performance of the classifier. The image here describes the change in the coefficients over time. So this is our classification accuracy. And the classifier used again was the support vector machine, and the kernel used was a radial bias function, which essentially finds nonlinear separation between the classes, and the parameters were tuned and tailored given the features that we used by iterating different combinations of the parameters gamma and C, and we found the best accuracy possible. And testing this system showed that the accuracy for the system for gender classification was above 92%. So the next level of our proposed model is the cloud level, and the cloud will be serviced for computation of the evacuation model. When the classification of gender based on the speech samples of mobile edge devices is complete, the gender information will be sent to the cloud. And in this level, the gender distribution information will be used within for the evacuation modeling algorithm and will be sought to accurately plan the best fit evacuation model. The cloud will act as a transceiver and will transmit the evacuation model back to the user for deployment in a crisis or evacuation situation. So, one of the main considerations for the system is the localization or the spatial distribution, basically where the occupants are located within the building. Um, and another consideration is in combining the gender distribution information with other metrics um, for an even more accurate evacuation model. And the ultimate goal in the future would be to test the system in an evacuation scenario, including from the data acquisition all the way to the deployment of the evacuation model to the user. So, to summarize, our MEC based system was presented, which used speech data obtained from mobile edge devices in conjunction with edge servers and cloud servers. And the speech would be used to compute the gender distribution at the edge levels, and the cloud servers would be used to compute the evacuation model. The model would be relayed back to the user for use in an evacuation scenario. And this, in turn, again, is just taking a step in bridging the gap between behavioral science, mobile edge computing, and machine learning concepts. And thank you very much for listening. And I hope you have a good day.